Hello guys, welcome to the Senior High School Mathematics Forum. Today we are going to deal with higher derivatives and Bogadam's shortcuts. My name is Steven once again. Higher derivatives simply means the a function gotten by the continual differentiation of a particular function. That's so we differentiate a function continuously to get the higher derivatives. And Bogadam's shortcuts are just shortcuts that are not recognized by Y, but they are very convenient to be used to get answers so simple and straight without tedious work and then suffering, going through a lot of mathematical um, suffering. So let's move on. Let's start so that you get to know what higher derivative is. Higher derivative, we say when we have a function y is equals to f of x, then the higher derivative of this particular function will be dry over dxr, where r is a member of natural numbers. Why am I saying it's a member of natural numbers? You can't tell you that find the half derivative of find the 3/4 derivative of find the 7/5 derivatives of. No, what they will tell you is that find the third derivative, find the fourth derivative, the fifth derivative, and onwards. So that is why r is a member of natural numbers. Have you seen that? So now let's quickly solve some examples so that you get to know what I'm really talking about. I have with me some few questions here. Guys, here are the questions. And the question one says that find the keep y dx keep of y is equals to f of x is equal to x power 7 plus 3x power 5 plus 2x squared plus 1. So how do we solve this, guys? Let's move on. The first told us to find the keep y over the x keep. So this is our focus. Now we have our function y to be equals to x power 7 plus 3x power 5 plus 2x square plus 1. Have you seen that, guys? This is our function that we are to find this. So what we will do is that, as I told you earlier on, you differentiate assiduously, continuously. Have you seen that? So in doing so, the first differential of this particular function will be, I will not write the basic things there, you know them already at the beginning of the video, at the beginning of differentiation. So I assume you know them, even if you are watching this only video. So dy dx is equals to 7x power 6 plus 5 times 3, that is 15x power 4, and then plus 4x. Have you seen that, guys? You will just use the differential notation. If you haven't done that before, there's no need for you to jump. You have to go back and learn how to differentiate functions this far. So moving forward, finding the square y dx squared will be 6 times 7 will really be 42, but let me verify that in order not to make a mistake. Okay, 42. So that will be 42x power 5 plus 60x power 3 plus 4. As I told you earlier on, if you don't understand why we had this, why not? We differentiated this to get this. But if you don't still understand, go and watch videos about how to differentiate functions before you now get to this far. So we now have the keep y, the x keep, to be equal to 5 by 42. What will you get? 210 x power 5 power 4 rather, x power 4 plus 180 x power 2. So this one will be 0. This is really our answer, the keep y, the x keep. If you want, you can do any factorization, whatever you want, but this is our answer. So now, actually, we have gone like through 3 steps. This is one. First of all, we differentiated this to get 1. We differentiated this to get 1. From there 2, then from there 3. So this one is the first derivative, second derivative, and then third derivative. Have it onwards like that. So the number of times they want you to differentiate it, you can still be doing till you get 0. There the function will be 0. So let's move on. I'm really going to show you how to use a shortcut to get that. So the shortcut is, when you have a function f of x is equal to ax power n, then we have the r y over the x power r to be equals to m permutation r multiplying by ax power n minus r. Have you seen that, guys? So using this formula, our r should be equals to 3. Then we will have the keep y over the x keep to be equals to, what is n? What is n? So we apply this to each term. Let's write the question down. The question was saying that y is equal to x power 7 plus 3x power 5 plus 2x power 2 plus 1. Have you seen that, guys? And this formula really have some condition. It has some condition. So those conditions, we'll look at them. So let's solve this one. As we solve, we will look at them alongside. So we'll have the keep y, the x keep to be applied to this and that onwards. So we'll have 7 permutation 3 multiplying by x power 7. Have you seen that, guys? Here the coefficient is 1, so 1 can be like the a. So plus, in that order, 5 permutation 3 times 2 times x power times 2 times x. It is times 3 rather, times 3 times x power 5 minus 3. Have you seen that, guys? Then that one will be plus 2 permutation 3 times 2 times x power 2 minus 3 plus 0 permutation 3 times 1 times x power 0 minus 3. So this is actually it, guys. So using the formula, that is how you will do, and then just get your answer straightforward. You will say this and that are the same, assuming they were saying you should find the 12th derivative. would you say they are the same? No. So that is why this is a shortcut. Have you seen that, guys? So now the conditions will now be placed here. One, n should be a natural number. If n is not a natural number, it won't work with permutation. That is one condition. So n should be a natural number. That is where it will work with permutation. If you have half permutation, even zero, it will not work. Half permutation, zero, it will not work. If you want, try that in your calculator, or on your calculator rather. Then let's move on. Also, another condition is that n should be greater than or equal to r. N should be greater than or equal to r before the permutation can work. N should be greater than or equal to r before the permutation can work. So these are all conditions. So, and another one is that when n, because it's just gotten from this one, when n is less than r, that means that when you press it into your calculator, you will get something like an error. So this formula, using this formula, it simple tells us that wherever you get an error, you denote that place as zero. You give zero to that place. So when you have something like 0 permutation 1, that place will simply be 0 because it will give you an error. And that is the assumption and the conditions placed. So now let's quickly do so here. So we can see that we have 7 permutations, 7 7 throughout, 7 5 and 2 throughout. So they are all this thing, natural numbers. Now let's move on. 7 permutation 3, that means that 7 is greater than 3. That one works. 5 permutation 3, it means that 5 is greater than 3. That one works. 2 permutation 3, it will not work. So this place will give us an error when we press into our calculator. Therefore, we denote this place as 0. And then this place too will give it a 0 answer. So both, we give them a 0 answer or zeros. So now it will now be left with these two. Have you seen that, guys? So following the conditions and the assumptions very well. Then moving on, we'll have 7 permutation 3. What will 7 permutation 3 be? 7 permutation 3 to be 210. So 210, then we'll have it, sorry, this is actually minus 3. So we'll have it times x power 4 when you subtract the 3 from the 7. Then plus 5 permutation 3, it is 5 permutation 3, it is 60. So you have 60 times the 3, what will you get? 180. So it will be 180 times 3, so it will be 180 x squared. So this is our answer. We've gotten our answer. So now, is this answer not the same as this one? Yeah, they are the same. So now someone may ask, so how did you get this? Oh, don't worry, I'm about to explain that. So guys, really, as I told you earlier on, when you are given a function like this, f of x is equal to ax power n, and you find the first derivative. Let's say we are finding 3 derivatives of it, like the third derivative. So when you find the first derivative, what will you get? You will get n multiplying by ax power n minus 1. Have you seen that? When you find the second derivative, that is finding the derivative of this one will give you the second derivative. So meaning you will multiply this one by the whole of this again. This one's become this thing. a constant. So have n minus 1 multiplying by n multiplying by a x, then you have minus 1 on top there. It will now be minus 2. Have you seen that? So moving forward, we will have f prime prime of x prime 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 of x to be equal to same. So guys, have you seen that? Multiplying by n, then multiplying by a times x power n minus 3. So that is really the third differential or the third derivative. Now, rearranging this constant, we'll have n times n minus 1 in bracket times n minus 2 in another bracket times a times x power n minus 3. Have you seen that, guys? So now we were asked to find the third derivative. So I thought of it, said let r be that third derivative. Then n should be the exponent of the x. So r should be the number of derivative, that is the 3, and n should be the exponent. So which particular mathematical evaluation will be simpler and it will also be equal to the same thing? So looking through glancing through the topics, I realized that permutation would be able to do that. So n permutation r, which is 3, so n permutation 3 will actually give you this one. Have you seen that, guys? But I denoted r as the number of differentiations. That's the whether the second derivative, the third derivative, and onwards. So then I modified it to n permutation r multiplying by a and multiplying by x power n minus r. So this is simple. You can even use it to find the 50th derivative without differentiating and differentiating and 50th derivative. What you need to do is that you follow the conditions. The 50, that means here should be greater than the 50, and then that works, and then that n should also be what? A natural number. That is all, and you will get your answer rather than differentiating and differentiating and differentiating and differentiating. So let's move on. Let's move on to solve the other questions. So I really have with me another one here. Here is it. So that needs this thing. This question we need to differentiate to find the third derivative, and it needs the chain rule to do so. So I assume that you know the chain rule now. If you don't know it, you have to go and watch the videos about it. So I'll go straight to just differentiate it very fast without passing through the necessary procedures, because you should know it by now by watching that video. If you don't understand, go back and watch that video and then come. There's no need for you to jump to skip. So now we have that function to be f of x is equal to y, which is equal to 3x plus 2 all power 7. This is good, and they are saying we should find the keep y over the x keep. Have you seen that? So in finding that one, what we will do is that we differentiate continuously till we get to that. So the first derivative will be dy dx. We are solving it like that. It's equal to, I'm not going to use the chain rule or what explain into deep like that. I'm just straightforward differentiating it because you know chain rule already. You can use it. So 7 multiplying by 3, then multiplying by 3x plus 2 power 6, which will be equals to 21 multiplying by 3x plus 2 in bracket power 6. Have you seen that, guys? Then we'll have the square y dx squared to be equal to, this will be 126 multiplying by, let me really test that before I make a mistake, because I made a mistake somewhere of which I don't want to upload that video. So I have 6 times 21 126. So that is really 8. So 6 times 21 is 126. Let me come. We are differentiating this. So we'll have it to be 6 times 21. Sorry, to be 6 times 21 times 3. Now times 3x plus 2 in bracket power 5, guys. So um we will have 6 times 21 times 3, 378, 378 into bracket 3x plus 2 power 5. Have you seen that, guys? Now the third derivative will be the keep y dx keep, which will be equals to 5 times 378 times 3. We are differentiating, that means we've differentiated the inside, then times 3x plus 2 power 5. Guys, have you seen power 4 now? Because we decrease it by 1. So now we'll have 378 times 5 times 3, and that will be 5670. 5670 into bracket 3x plus 2 all power 4. So guys, this is really our third derivative of that question. So now let's move on. Let's move on to solve the others. So in moving on, but we'll solve this with my shortcut, and you will see, and it has conditions. That's why you might have to stick to this, because if you go and do so, you will be getting errors. Without knowing the conditions, you will be getting errors. Good. One of my shortcuts says that if you have a function f of x is equal to ax power n, good, then, sorry, not this way, not this way, it's equal to, then you have it ax plus b power 7. Have you seen that, guys? And then you have like c outside. You can have c or anything outside, that really doesn't matter. So the differential of the first derivative, the d, so let's say this is y, so the ry dxr is equal to, this is power n and not 7. So we'll have n permutation r multiplying by c multiplying by a power r multiplying by ax plus b bracket close power n minus r. So this is really the differential. So now let's differentiate it. But let me tell you the conditions here before you do so. Now, you see this particular expression? You should have an expression in this form before you can use this formula. That means that this should be a linear expression. A linear expression. A linear expression. So it should be a linear expression. That means that the power of this x should not exceed 1. It shouldn't surpass 1. And c can be anything. A can be anything apart from 0. That one, they are saying it should be a linear. So it can be anything apart from 0. C2 can be anything apart from 0. But B can be anything at all, provided it is under the rational real numbers rather, because you are limited to real numbers. And then n, as said in the first one, should be a member of natural numbers. So that is it. It should be a member of natural numbers. If n is not a member of natural numbers, then this formula cannot be used. Have you seen that this one condition and it is limited? Have you seen that? So 2, as said in the earlier one, n should be greater than or equal to r. Simply as that. I will not do more explanation because you know why. Corresponding to this permutation, you know why. It is having an association with the permutation. Why it is so. Then when n is less than r, you know already the differential is assumed. This one is an assumption. It's assumed to be 0. So we assume to be 0. Though your calculator will say an error, it will give you an error, but it is assumed to be 0. Like it is always assumed to be 0. So now, let's move on. Let's move on. So we have it as y is equal to into bracket 3x plus 7 all power. So all plus 2 is plus 2 all power 7. So using this formula, we will have c to be 1 because nothing is there and it's 1. Then we will have a to be 3 and we will have n to be 7. Have you seen that, guys? Then we will have r to be 3 because they asked us to find the third derivative. So putting everything into the formula that was formulated by me, you will have d power 3 y dx power 3 to be equal to 7 permutation 3, 7 permutation this 3, the number of differential, times c, which is 1, and then it is not sensible to do so. So because 1 times anything, any quantity is still that quantity. That is, it is an identity in multiplication. So you just write that quantity down. So times a power r, so 3 power 3, then times the bracket open, we'll have our expression there, which is 3x plus 2, then power 7 minus that 3, the r. So, in simple terms, 7 permutation 3 will be what? In a brief solution rather, 7 permutation 3 will be 210 times 3 power 3. 3 power 3 will be 27, I believe so. Yeah, 27. Then times bracket open 3x plus 2 all power 4. So guys, you are going to get 210 times 27. 210 times 27. What are you going to get? You get 5,670 rather. So get 5,670 multiplying by 3x plus 2 exponent 4. So this is the answer. Is it not the same as this one? Is it not the same that we got here when we differentiated continuously? But this one we just differentiated once. But this one it was continuously. But in order to use the formula, you have to know the conditions that I told you earlier on. So let's move on. If you really want to know how I got it, let's still use this same function and then derive it, get to know how I got it. Now, when we have something like f of x is equal to that same function c multiplying by ax plus b all power n, and you find the first derivative using, you find the first derivative. This one needs the chain rule. When you use the chain rule, as I taught you earlier on in the first videos, you will get n multiplying by c multiplying by a, then into bracket ax plus b, bracket close, power m minus 1. Have you seen that? Then when you differentiate again, this one will be a constant, so you shouldn't think like, because this one was a constant and not a function. A constant and not a function. They are not functions. They are not denoting functions. So this one will be a constant, so it doesn't need any product rule. Differentiating again gives the second derivative, which will be n minus 1 times n. Have you seen that? Times c. This c will always be there. It is a constant. We can even isolate it. Times a, but we always differentiate the inside as well. So times a again, then times ax, then times ax plus b in bracket all power. When we subtract 1 from here, it will now be minus 2. Have you seen that, guys? Then again, moving on, third differential will give us this. Have you seen that, guys? Times n minus 1 times n times c times a times another a when we differentiate the expression inside. That's really the chain rule. So times, we are differentiating this to get that ax plus b in the expression in the bracket power n minus 3. Have you seen that? So now, guys, rearranging this will be f prime prime of f prime 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 of x to be equal to n times n minus 1 times n minus 2 multiplying by c. There are three a's here, so multiplying by a power 3. Have you seen that? Then multiplying by ax plus b power m minus 3. So this was what I first did. Guys, have you seen that? This was what I first did. Then I said, okay, let R be the differential, the number of differentiations, the differentials. So I was sitting one day when the spirit came to me that I should do so. So I said this will actually be the number of differential, whether second or third, that way. So, and third differential, meaning when you differentiate 3 times, you will get this. So I really replaced this second 2 times we had this, once we had this, and then 3 times we had this. So I really replaced R to here and there. Have you seen that? And also realize that the exponent and permutation R, which is 3, was this. Have you seen that? And also R was 3, here 2, 3, same. So now I concluded by saying that simply here, by saying that the formula is this way, and that was how I came about it. So let's move on. And we have another question here to solve. So this question, that find the square y dx square of, so we are differentiating that of the given function, the function that they have given us. So in finding that, guys, let's rewrite it down. In rewriting it, we write it down as y is equal to 4 over x squared 4 over x squared plus 4 over x squared plus x cubed plus root of x. Have you seen that, guys? Now, I told you earlier on in the first videos that in order to differentiate this, you need to rewrite it in a form that you can differentiate. So y is equal to, you have to use your indices knowledge. So 4x power minus 2, I will not explain because those videos are there for you to know. So when you get here, you can easily be following me. So plus x cube, then plus x power half. Have you seen that, guys? Using my indices knowledge, I've rewritten it. So now let's differentiate this. We will have it as the y, but we were told to find the square y the x square. That means differentiating it twice. So let's find the y the x and then find the square y the x square, because that's the only way we can do differentiating it continuously till we get to where they want us to get to. So we'll have minus 2 times 4, we'll have minus 8 x power minus 3. I will not explain, as I told you earlier on, plus 3x squared plus half x power minus half. That will be our differential, our first differential. Then we'll find the second differential, which is the one they want, which is equal to, have you seen this? So you differentiate this one together, not this one again, this. So in differentiating that one, we get 24x power minus 4 and plus 6x minus 1 over 4x power minus 3 over 2. Guys, have you seen that? So after this, you now rewrite it in a more sensible form, because you've learned indices and others like SAS. So 24 over x power 4 plus 6x minus 1 over 4 multiplying by square root of x power 3 Have you seen that rewriting this that way? If you can't rewrite that one, that means that your indices is not well stacked. So let's move on. This is really the answer. So now, um, if you want to use a shortcut, they could have told you that differentiate it find the 12th derivative or 15th. They don't stress you there. So, but I just want you to know those shortcut formulas. So the shortcut formula is simply this one. Is this one. If you don't do it this way, then those halves and then negatives exponents cannot be used for permutation, because if you do so, it will give you an error. Thereby, you leave them this way. Have you seen that? So that means that when you have something like this, let's just write it in the more convenient way. No. So y is equals to 4x power minus 2 plus x cube plus x power half. Have you seen that? This one is not in the form of this, but like I'm talking of the coefficient. It requires this coefficient. Have you seen that? So like, let me just explain to you here. When you are having a function like this, f of x is equals to a x power n, and n is any like a member of rational numbers, real numbers rather. It's a member of real numbers. You can use this formula. The r y dx r is equal to this a multiplying by, I will not really explain this one because the video is getting longer, the duration. So I'll just show you how it came about. So a multiplying by n in square bracket multiplying by another bracket n minus 1 dot 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 in that order, just multiplying in that order to n minus r plus 1, meaning to a value less than r, then bracket close. Then we will have it multiplying by x, then multiplying by n, that's to this function, multiplying by n, sorry, multiplying by x power n minus that r. Have you seen that? And then this one is not limited. It has no limit, like limitations. It has no conditions. It can be used anywhere at all. So when we have something like this and we are to differentiate, we apply this to each of the terms, because this one was like a term. So in differentiating this one, finding the second derivative, what do? We say the square y, straightforward, the x squared should be equal to, then 4 aside. For this one, we are differentiating this one. Then they said to a value less than 2. So meaning to a value n minus a value less than 2. Have you seen that? So we'll just get to here alone and not to 2 or 3. Because if you are finding second derivative to a value to n minus a value less than 2, third derivative to n minus a value less than 3, in that order. So we have 4 times, then the n is negative 2 here for this one, for this particular term. So we have negative 2 multiplying by negative 2 minus 1. That's where we will stop to a value less than this particular differentiation that we want. Then times multiplying by x power minus 2 minus 2. Have you seen that? Minus r. That same thing to this term too. So we have it has no limit, whether it's positive, negative, what. So we have plus, the coefficient is 1, so it's not sensible to write that one since I told you it's an identity. So 3 times 3 minus 1 to a value to 3 minus a value less than 1. Have you seen that? 3 minus a value that is less than 1. If I don't do that way, someone will write it as an expression form 3 minus 1 less than 2. and say 3 minus a value less than 2. So 3 minus a value that is less than 2. So let me just say it that way. So this way, and then not half or something like that. Not half. You cannot subtract half from it and say 3 minus what less than what I said. So no, 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 no. It is not like that. They should be whole numbers. Whole numbers. That is natural numbers. They should be natural numbers. And then they should even be whole numbers. Zero is included since your first derivative is part of them. Zero is included, so they should be natural, whole numbers rather. So let's move on. Then this one times x. Have you seen that, guys? So that one times x power. That one times x power 3 minus 2. Then we have plus. We have plus half times half minus 1. Have you seen that? So times x power half minus 2 direct. So computations give us, this is minus 3 times 2. That will be what? 6 times 4, 24. So we'll have 24, 24 minus 2 times minus 2 rather. We'll have minus 4. Minus 2 minus 2 is minus 4. Then we'll have 3 times 2 here plus 3 times 2 here, 6. 3 minus 2, that will be 1. So we'll have 6x. Then plus, so half minus 1 is minus half times half minus 1 over 4. So plus minus 1 over 4. Then half minus 2 is what? Minus 3 over 2. So we'll have times x minus 3 over 2. Have you seen that, guys? So this is how it is. So rewriting it, we will get 24 over x power 4 plus 6x, then plus, it is rather minus 1 over 4 square root of x cube. Have you seen that rewriting this? So this is actually the same thing as we got here. Have you seen that? So it's still the same, guys. So the video, in order to prevent it from getting to an hour, I give this one to you as an assignment, and also formulate your own shortcut based on how to solve that one. So that is it. And then in the next video, let me see it at the comment section. Your answer. Let me see your answer at the comment section, and also your formula. And thank you. So let me just quickly give it to you. I'm really talking about this one. So it is an assignment to you. Also drive your own shortcut to solve it, and also solve it well. Solve it and also think about how to solve it using your own shortcut. And that is it. Thank you. Please share this video, subscribe, turn on the notification bell for more videos, and also like. Please comment any mistake that you see. Comment so that I'll not be making those mistakes, and also bring to you the best videos of mine. Thank you.